Okay, hey, welcome back. Now we are going into a couple practice problems dealing with ionic bonding. Here's a quick review of the rules that go with ionic bonding so that you can see. Okay, when we're naming an ionic bond, we first name the metal all the way. So if we have sodium and chlorine, that would be sodium. We would name the metal out fully. Then we shorten a non-metal and add the "ide" ending to it. So chlorine would be shortened to chloride. Okay, so that'd be sodium chloride. Now, if we are doing transition metals, remember we have to add Roman numerals in there and account for oxidation numbers. Don't forget to do that part. In saying that, how we're going to work these next few problems is I'm going to give you two elements and we're going to say, hey, they're going to combine together to form an ionic compound, so we're going to name them, and then we're going to come up with the formula for them. So let's keep going. Lithium plus oxygen. Well, let's do the naming first because that's going to be the easiest one. Lithium is our metal, so we're going to just say the name out all the way. Lithium. Oxygen, we can shorten to oxide, so we have lithium oxide is the name. Then, if we want to do the formula, I'm going to write down my two elements. So I have lithium, Li, and oxygen, O. I'm then going to go look at their oxidation numbers. Okay? Lithium has a +1 oxidation, while oxygen has a -2 oxidation. Those are going to be treated as superscripts for now. Because of our crossing rule, we can then cross them down, and we get that 2, we can forget the signs, that 2 goes down by the lithium, so we got Li2, and the 1 from the lithium goes down to oxygen, and because it's 1, we don't have to write anything, so it's Li2O. So that's going to be our formula for it. So lithium oxide is Li2O. Okay, next one, magnesium plus chlorine. Well, naming it first. We put our metal's name out all the way. Magnesium, okay, not hard. But then our non-metal, we shorten and put the "ide" ending. So chlorine becomes chloride, so that'd be magnesium chloride. Okay, so there's the name. Now if I want the formula, I'm going to write each element out, magnesium Mg and chlorine Cl. Magnesium has a +2 oxidation and chlorine has a -1 oxidation. Those are going to go as the superscripts. Now we just cross them and take away the symbols, and we get Mg1Cl2, or in other words, we can omit the 1 and just say, hey, we know that's there, and be MgCl2. So magnesium chloride is MgCl2. Okay, what about calcium and nitrogen? Well, name our metal. Calcium. Nitrogen we shorten from nitrogen to nitride, so it would be calcium nitride. So now we've got the name calcium nitride. Let's do the formula. Calcium has a +2 oxidation and nitrogen has a -3 oxidation. So first of all, I'm going to write calcium and nitrogen. Then I'm going to put their oxidations as superscripts. Then I'm going to cross them. So my 3 from my nitrogen is going to go down by my calcium, and my 2 from my calcium is going to go down by my nitrogen. That's going to give me Ca3N2, and that's going to be calcium nitride. Now let's go with potassium and fluorine. Okay, potassium, we're going to say out our metal, potassium, and then shorten our non-metal fluorine to fluoride. So for our name, it's going to be potassium fluoride. Now, if we want to do our formula, let's write out our potassium, which is K, and our fluorine, which is F. Potassium has a +1 oxidation, and fluorine has a -1 oxidation. If we put those as superscripts and then cross them, then we're going to get K1F1, or just omit the ones, KF is your formula for potassium fluoride. Now let's talk about a really quick rule when it comes to the subscripts. If you can reduce, you need to reduce. Okay, so for instance, if they both have a subscript of 2, you can take that out and it's just going to reduce to its lowest form. So for instance, beryllium and sulfur. Beryllium, first of all, the name is going to be beryllium sulfide, and beryllium has a +2 oxidation while sulfur has a -2 oxidation. So let's just work this out real quick. Okay, if I have Be with a superscript +2 and S with a superscript of -2, we cross those, so we both have a 2 for subscripts on the bottom, and because it's Be2S2, we can take a 2 out of there, and it's just going to be BES is our chemical formula. So you can reduce it down to its lowest form. But remember, whatever you take out of one, you got to take out of all of them. Okay, so now we have calcium and oxygen. Okay, if we write those down, we have calcium Ca and oxygen O. Calcium has an oxidation number of a +2, and oxygen has an oxidation number of a -2. If we cross those, we get Ca2O2, which we can reduce out to CaO by just taking the 2's out of both ends, which is calcium oxide. Now we can talk about transition metals. So let's say we have iron 2 and bromine. Well, first thing we're going to write is our iron, Fe, and then it has a 2 oxidation state, so we're going to put a 2 as a superscript. Then we also have bromine, so Br. Well, bromine's oxidation is a -1. So we cross these now, and we get Fe1Br2. We don't have to state the 1, so it'd be FeBr2, which is iron 2 bromide. Now let's go to copper 4 and oxygen. So copper, Cu, has an oxidation state of 4, so we put that as a superscript. Oxygen has an oxidation state of a 2, so O, and then a 2 superscript. Cross them, we get Cu2O4. Well, we can reduce that and take a 2 out of both of them. So now we get CuO2, and that would be copper 4 oxide. Notice here, though we reduce the chemical formula, we still have copper 4. Even though when we recross and reverse this reaction, we get 2 with our copper, the fact that our oxygen is a 2 means we must have had to reduce it. So we have copper 4 oxide because we reduced the 2 from the 2 and the 4. Finally, we have zinc 2 and nitrogen. Zinc, Zn, has an oxidation state of 2 because it's stated, so we'll put it as a 2 as a superscript. Then we have nitrogen N, who has an oxidation state of a -3. Now we just cross our oxidation states and we get Zn3N2, or zinc 2 nitride. There's nothing we can reduce here, so that's it, Zn3N2. In saying that, I hope these practice problems helped you out, and keep up the good work, and see you next time.